Okay. Uh, Oops. So, what you want? The first, let's see, yeah, the second question on that. What we want to do here is we want to set up a Lagrangian, right? With, with this production function and the cost function. Okay. ¿Cuál es el objetivo aquí? Sí, es la reflexión. Esto yo no sé qué es exactamente. Ok. Pero y, ¿verdad? Era ingreso. Este es costo. Y el precio de acá, te digo que debería ser V. Y el precio de laboral es W. Pero eso es el objetivo.
The objective is the constraint.
You're good, except right when you write out the constraint, right? You subtract off.
Ah, sí.
Okay.
Se me fue.
Okay. Again, what's our objectives? ¿Qué era tu
Daniel,
¿Qué era el objetivo?
el objetivo, la función de costo, minimizar el costo.
Okay. Pero la estás poniendo en la restricción, en la lambda, ¿verdad?
Ok.
En las grandes.
Ah,
es la
bien.
restricción. Estamos minimizando costo con la restricción de tecnología.
Ok. Que sería al revés.
Exacto. Okay. También vamos a seguir con las condiciones. También no necesitas hacerlo, pero pues, algunos cambios. ¿Verdad que no? Que no puedo usar.
Es lo mismo, es como era referencia gente. Lo que pasa es que la que construir uno por el
Ese es el objetivo.
y el objetivo que explica no sé qué va a aparecer por acá.
Este es el objetivo. Entonces, la primera cosa que vamos a hacer es escribir el grande con este siendo el objetivo, ¿verdad? Aparte, y eso es lo
Son diferentes aquí. Más bueno.
So remember, a Lagrangian, right? You have an objective, right? And you have a constraint, right? At least one constraint. So the objective function always goes first, right? That's what we're trying to maximize optimize. In this case, we're trying to minimize it, right? Given our constraint, and here our constraints technology, our production function. Okay, so how does this production? So to get the constraint, right, we just basically set it equal to 0. That means q minus a to the 0.5, L to the 0.5, right? And then that's our objective. We want to minimize, that's our constraint. That's our constraint. We want to put that, right, in our constraint and multiply it by the Lagrangian multiplier lambda. So most of you have written the cost function. And so the next step is to set up the Lagrangian, which I think most of you have. I'll give you a couple more minutes so everybody can type up. Sí. Quería ser él al contrario. Entonces, primero, first order constraint with respect to K, the second with respect to L, okay, and then you're going to do one with respect to lambda, which ends up giving you basically a production function. Now, I noticed that most of you, almost all of you, started with the production function as a constraint, because that's pretty similar to what we did with theory of the consumer. But our objective is different. With theory of the consumer, we're maximizing utility. Here, we're minimizing costs. Esto de tú, condiciones, la restricción, básicamente la igualas a cero. Entonces la pones aquí, de tú menos eso. Okay, so I'm going to set up the Lagrangian. Here it is. I like the little fancy L, but the font always gets screwed up and it goes back to this everything. So here I have B times K plus W times L plus lambda, our Lagrangian multiplier, times our constraint, Q minus K to the 0.5, L to the 0.5. Now, once you have that, what we want to do is we want to take the first order conditions with respect to all the unknowns. What are our unknowns in this case? Perfect. K, L, and lambda. So, you take the partials, right? The Lagrangian with respect to those three variables. First K, then L, then lambda. And well, order doesn't matter, but those are the three first order constraints, or conditions that we want to, first order conditions that we want to take. So if you haven't, go ahead and take those partials. Es la primera. Siguiente. Entonces aquí, no, aquí, no acá. Entonces, sí. El tercero está aquí, que haga la misma cosa que él, luego la lámpara. Marginal product. Sí. Esto es negativo con 5, ¿no? Entonces hay la misma cosa por, ese es W,
Ya. Y después lo pongo.
pero este no es W, este es
Oye,
contrario. Okay, you're missing the last first order condition. But that's okay, I see what you're doing, and that's okay. You don't need that last first order condition until after you finish, but we usually write them out for three. So, go ahead.
Algo así.
Este es para,
Donde igual.
sí, pero okay. You're right. Okay. Except you did the math wrong. Okay, that's fine.
Okay.
Lambda, okay, yeah, okay, perfect. You just set the lambdas equal to each other, right, here. Set this equal to that, and then, yeah, instead of the minus, but, yeah, that's perfect. But the truth is, the marginal product of labor, right, is just this part right here. 0.5 delta negative 0.5 3 0.5. That's the marginal product of labor. That's the price of labor, and that's the price of capital. Right? So what we get, right?
Sí, porque esta sala
Sí, las razones de los productos marginales, ¿verdad? O la razón de los productos marginales va a ser igual a la razón de precios de capital y natural. What you're going to get is V over W equal to ratio of marginal products, and ratio of marginal products, you know what that was called? Marginal rate of, sí, technical substitution, yes.
Técnico.
Es good.
okay. Okay.
Okay. It's just a little math, that should be a negative. Okay, so the negative 0.5, and we do LCI. Acuérdate que cuando usamos el derivado es menos 1, entonces 0.5 menos 1 es negativo 1. Okay. So here are first order conditions, right? First, the Lagrangian with respect to L, then with respect to K, and then with respect to lambda. Right? The first one, right, was W times K, so we left the W, then it was, I'm sorry, W times L, and that's with W, then B times K, there's no L there, so that's equal to 0. And then, the second part of the constraint, lambda times 0.05, K to the 0.5 times L to the negative 0.5. And do the same thing for K, and we end up with B, of course. The WL doesn't have K in it, so that's 0. Lambda 0.5, K to the negative 0.5, L to 0.5. And then finally, the Lagrangian with respect to lambda, which is just what's left inside the constraint. This- Which is just this part right here. Okay, now, once we have the first order conditions, I'd like you guys to solve for lambda in the first two. So just solve for lambda in the first two.
Creo que porque hay que, en esta máquina, en esta aquí, el objetivo, hay que sustituir la Q solamente y sacarlo.
Sí, acuérdate que estás diciendo, tú quieres K, ¿verdad? En términos de los variables fijos, los precios y Q en este caso. Lo que no quieres es K en términos de L o L en términos de K, porque no quieres un variable aleatorio. You don't want one random variable in terms of another random
Sí, sí,
variable.
quieres
You want to get rid of, yes, you want to get rid of the random variables. And
Sí.
our three random variables, K, L, and lambda, so we want those in terms of just our fixed variables.
Okay. Y entonces, lo que estamos haciendo es sustituir eso. Yo, por ejemplo, cojo acá, la sustituyo aquí. Al sustituir aquí, puedo despegar para acá y tenerla en términos de Q, W y V, y eso es lo que me minimiza, o sea, lo que me minimiza mi costo. En
Ese es
términos
el K que
de-
te minimiza el costo deteniendo L fijo.
Ok, me lo fijo.
Y viceversa, cuando tienes L,
Si lo sustituyo, dale Q y te da Q por eso.
okay, this is the marginal product of capital or the marginal product of labor. This is the marginal rate of technical substitution. Solamente para que no te confundas. Es fácil. La estás haciendo más difícil que necesitas hacer. Ok. Pero mira, te falta el L aquí, ¿no? Entonces, L al punto 5. Y aquí te falta el K. Y eso la puedes escribir como L al negativo punto 5 en vez de con 1. Eso sí. Si es mejor para ti en tus notas, déjalo. Okay. So here I have it in my second first order condition and here in my first order condition, the order I got it. So those are lambdas. And notice I set them equal to each other. Okay, now that we have solved for lambda in our first two first order conditions and set them equal to each other, what I want to do is rewrite the equation. Right? I want the ratio of prices, and the price of capital is V and the price of labor is W. Right? This happens to be the marginal product of capital, right? And so if I took my production function and I took the derivative with respect to capital, right? That's my marginal product of capital, that's it. This here, if I do the same thing with respect to labor. So do you guys remember what the ratio of the marginal products were in cost-plus rate of the firm? In this case, the marginal product of one input to another?
Substitution and
Close. Marginal rate of technical substitution, and it's really the same thing that we had before. As a marginal rate of substitution, we talked about utility functions. We're doing the same thing mechanically, right? But we need to call it something different so they can technical it. So it's the marginal rate of technical substitution. So I rewrite the equation, right? And I get the ratio of prices, right, is equal to the ratio of the marginal rate, the marginal products, which is basically, right, where our isoquant touches our isocost, right? Now, of course I can, actually, let me go ahead and do the math here for you guys. So I have W over V is equal to 0.5. I had W over V, right? Over 0.5. It's going to be K to the negative 0.5, L to the 0.5, over K to the 0.5 times L to the negative 0.5. Now, going back to the algebra, K over 0.5 is in the denominator, so it's really, if I wrote it over here, it's K to the negative 0.5. K to the negative 0.5 times K to the negative 0.5 is just K, right, top. And over here, I have L to the negative 0.5 in the denominator, and I have L to the 0.5 in the denominator. I can bring that up top, right, and I'll get L to the 1. So that's why I have here, V over W equals 0.5 over 0.5, which is just 1, K over L, and I solve for K, and K equals W over V times L. So now I have K in terms of L, or I could have wrote it out in terms of K, but it doesn't matter.
sería al revés, en este caso sería L over K.
Sí, L sobre K.
L sobre K.
L sobre K, pero acá, la K es W.
Did I mess up?
Because this one, you bring the K down, K will be on the bottom, L will be on the top. L es la negativa, ¿eh?
Okay. Oh, you're right, because I.
Sí, pero acá está bien, acá está bien. Es en el medio.
Sorry. Okay. Sorry about that. But okay, so now we have K in terms of L. And we went through, we burst through our ratio of input prices equaling the marginal rate of technical substitution. And we know the marginal rate of technical substitution is simply the ratio of marginal products. So what I want now is I want you to plug in that equation that you have for K, right, back into the third first order condition, which is our constraint. Here. Okay. I'm going to have WBL 2.5. Entonces, aquí con los hijos campeones, yo tengo acá, yo voy a ver, escribe. En otro que está igual a W, dividido por B, ¿entiendes? En otras palabras, divide los dos lados por B, no es multiplicar los dos lados por B. Voy a multiplicar los dos lados por él. Bueno, los L's cancelan, ¿sí? Entonces, ¿qué está acá? Es sustituirlo en el que esté primero ahora voy a tener una función que solamente tiene L, no tiene K.
Queda esto, ¿no? Queda no, pues entonces la manera que se da N.
Okay. Ahora resuelvo para ella. Ok, ¿estás bien la matemática aquí? La W llega hasta el punto 5, los hechos son altas.
Ah, porque es de
Entonces, perfecto. Okay. Entonces, ahí tienes, en vez de tú, esto igual a 0. Y eso debería ser igual a 0. Entonces, ahora puedes igualarlo, y entonces resolverlo para que vea. Okay. Entonces, we get Q is equal to W over B to the 0.5 times L. Everybody's there. And now I just want to solve for L. Right? So I get L is V over W to the 0.5 times Q. So we got L in terms of non-random variables. Everything there is fixed. now that we have L in terms of random variables, you remember a little bit ago we had K in terms of L, right? Now, the truth is you can plug this into a lot of places, but it's easiest. So if I plug in my solution for L into what I had for K in terms of L, I can get the equation for K in terms of fixed variables also, non-linear variables.
En el original.
No. Aquí, no, ahorita.
Eso se puede controlar.
Aquí, lo que vamos a hacer, ¿verdad? Yo quiero sustituir aquí solamente L.
Pero la ecuación original tiene un punto 5.
La original, sí, pero resolvamos aquí. Entonces yo necesito sustituir lo que tengo para ella. En
Exacto. Que está es igual.
Aquí. Igual. Entonces, aquí yo tengo K en términos de L. Aquí tengo L en términos de los variables. Yo estructuro eso. Exacto. You start to catch. Okay, perfect. Wait a minute. We'll tell you what to do, right? Yeah, okay. Okay. Lo puedes simplificar, porque aquí yo tengo D.5, W.5, aquí tengo W a la 1, D a la 1. Con P negativo 1 y W a 5, pues la P. Bueno, ¿cuánto se cancela, no? Porque este es la 1, este es 1, perdón, este es B.5, este es, vamos a hacer el W, al 1, ¿verdad? Multiplicado por W al negativo punto. Entonces me quedo con WA. Perfecto. Y luego aquí es lo puesto B.5, B negativo. Sí, cuando está abajo. Entonces escribiendo, ¿ya la tiene? Yeah, but the Q, right? Okay, that's fine, you're right. So yes, the W and the 0.5, which is really negative, leave it at top, right? So it's just W to the 0.5. Here you have B to the 0.5, B to the negative 1, so down here would be B to the negative 1. So basically it's that, right? K is equal to that, when I switch the W and B around. Okay, so I plug that into K, right? I get W over V times V over W to the 0.5 Q bar, which I can write, right? v to negative 1 over v, or v to the 0.5 over v to the 1, which gives me v to the negative 5. I have w to the 1 times basically w to the negative 0.5, which gives me w to the 0.5. So I get w over v to the 0.5 times q, and therefore k is equal to w over v 0.5 times q bar. Okay. So now what I want to do is I want to calculate the value for the Lagrangian multiplier at the cost minimizing level of K and L. I have my equation for K and I have my equation for L at the cost minimizing level in terms of non-random variables. All I have to do is plug them into one of the two equations that I have for lambda that I solved when I did the first two first order equations. So I have two equations for lambda. I can plug it into any one of them. Ya sabes sustituir lo que tienes por K, y lo que tienes por L. Yeah, I plug in what I have for K, and I plug in for L. Cualquiera de los dos, primero, bueno, no primero, sustituimos por K y L a la misma vez. We're solving for lambda,
Okay.
the Lagrangian multiplier, right? In terms of non-random variables at the cost minimizing. In other words, I'm substituting what I have for K and L, right, into one of my equations for the Lagrangian multiplier.
Okay.
Yes, I do that. Okay, so I take my equations for K and L calculated in one, and my first order equations in part A. So here's one of my equations for lambda, and then I just plug in for K and L. So now, once I have that, it's just algebra. Ugly algebra. I'll leave it there for a while in case we haven't got to it. Okay. Ten cuidado porque uno es negativo y uno es positivo. En tu ecuación de lambda. ¿Sí? Eso es negativo.
Ya.
O aquí, ¿verdad? Como le dice ahí, tengo negativo punto 5. Ten cuidado porque es 0.50. No ten cuidado para tus notas. Si la pones, si es un número y la pones en calculadora. Okay, so I just rewrite this, right? I have the negative at the bottom, so I just bring it up top. And I can write it like this, 2v, WV to 0.5 to 0.5, 0.5 to 0.5, that gives me WV to the 0.25, and WV to 0.25. I multiply those. Oh, and I forgot the V, like 2V. And I get lambda is equal to 2V, W over V, 0.25 to 0.25, or 2V, W over V is 0.25, 0.5. So here I have V to the 1, and here I have V to the negative 0.5. And I end up with lambda is equal to 2, V to the 0.5, W to the 0.5. Muy rápido, should I go back? Do you want me to go back?
Yeah.
Sorry. Oops. There we go.
Lo que no entiendo es si estoy mirando, ¿verdad? La parte de arriba de ese número, V. ¿Dónde salió?
Ok. Estos K negativo 5. Yo puedo llevar K arriba y K punto 5. Ok. En hablando. Tengo la línea aquí arriba, ¿no? Ese es.
El 9.5 que es un medio. Cuando multiplicas por el vecino, pues. Gracias.
Entonces, viendo la álgebra, 2v.25 más punto 25, 2v.5, esto es v al 1, este es básicamente v al negativo punto 5, pues me quedo con v a punto 5, y w a punto 5. Esa es la solución para la preguntas. Entonces, by the way, in the practice exam, is it 0.5 and 0.52?
No.
Okay. Okay. See? ¿Fui muy rápido? Okay. Show that the cost minimizing point of an extra cost of the extra cost of obtaining an extra unit of output by hiring either added labor or added capital must be equal. The truth is, you've already done this. Because I solved for lambda in the first order equation, lambda in the second order equation, right? And then we saw, right, that those two are equal, and I can rewrite that as the ratio of prices equal to the ratio of marginal products, which is the marginal rate of technical substitution. So you've already done this. It's just plug it in. So the cost of hiring an extra unit of labor is W, and the cost of hiring an extra unit of capital is V. Both are assumed constant. The extra cost is denoted by our Lagrangian multiplier, which you already calculated. Okay, and there it is, but you've already done it, so. It. Okay. Questions? Okay. So the marginal cost of capital and labor, right, are as follows. I just take my production function, I take the partial with respect to capital, then the partial with respect to labor. I get the marginal product of capital, the marginal product of labor. And you see that that's exactly what's in our function for lambda. Okay, so I can rewrite lambda as V over the marginal product of capital, W over the marginal product of labor. Oh, sorry. So what would an extra, excuse me, would be the additional cost of producing an extra unit of output, Q, be at the cost minimizing point. You know this, right? Because you solved for lambda already. It's lambda. And you just have to explain it. Right? The Lagrangian shows how much the objective function will change when the restriction is relaxed by 1 unit. In this case, lambda is sometimes called the shadow price. So the cost will increase by lambda. So if I have 1 extra unit of output, my cost will increase by that much. Okay. The second exercise, for example, today, is the first thing I want to do is using the production function from 1, which is just Q equals K to the 0.5, L to the 0.5, that's a production function. I want to write a profit function for this firm in terms of price, capital, and labor. In general, how do we define profit?
Minus cost.
Revenue minus cost. In this case, total revenue minus total cost. Total revenue minus total cost. So total revenue we know is P times Q. So total cost. In this case, total cost is just cost, right? So I'm going to write P times Q minus VK minus WL. Now I just have one more, and that's Q, and that's where I want to substitute in my production function. So I have profit is equal to P times K to the 0.5 times L to the 0.5 minus V K minus W. Okay. So let's start off. Let's start off with my profit function, P times Q minus the total cost. C we defined as this. And of course, I plug in my production function for quantity. So there it is. That's our profit function in terms of price, capital, and labor. Where P is the price of the output. And of course, W and V is the price of the input. Okay. So now that we have a profit function, the next logical step, right, is solve for our profit maximizing level of K and L in terms of all our fixed or known variables. W and V and P are all fixed, and of course we want a fixed Q. So I gave you some hints. Start to solve for K in terms of L or vice versa, then plug that one into the production function. So the first thing I want to do with that production function is to do that is to take our profits, and I want to take the derivative in terms of K or L. Actually, both, but one first and the other. So I have my profit function. I want to maximize this, right? But I have two variables, so that's a problem. So the first thing I want to do is I want to take a partial and solve that with, take a partial with respect to one of the variables, K or L, set that equals 0, and then do it for the other variable. Luego después tomar el y este es pensé que iba a escribir más. Primero acá. Muy bien. Recuerde que el condicional es exponencial, mantenga todos los otros variables fijos. Esto
En parcial así con la última.
no entendí.
Le vamos a la deriva parcial acá, por ejemplo,
¿Sí?
en la última ecuación o en la tercera.
No, en la última, donde solamente tengo K y L. Acá es un exponente. Ok. Bueno, ok. Ok. Igual a los 2 a 0. Entonces vamos a hacer la misma cosa que hacemos ahorita. Yo voy a resolver por K en términos de L o L en términos de K. En cualquier de los dos ecuaciones. Solamente resuelvo L está aquí. Sí, so if you haven't noticed, we're doing the same thing that we did before with the Lagrangian, and we have a profit function. Basically, we're going to solve for L or K in either one of these, right, partials. Right? And then once we have that, I can plug it in wherever I want. I can plug it into our original production function, I can plug it into the other equation. Oh, sorry, I actually set them equal to each other. I did this a little differently, I'm sorry. But that's okay. Basically, I set them both equal to 0.5. I could have that as, it's not, I knew it wasn't lambda, but just an equation. And guess what? I get what I got a while ago when I did it with the Lagrangian. So W over V is equal to K over L, right? Which means is our profit maximizing level of K and L are going to be equal to our cost minimizing level of K and L. Okay, okay. So basically now we're where we were before we did our Lagrangian, where I have K in terms of L. Now I could have gotten to this the way I thought of originally. Well, not originally because this is original, but I could have, the way I thought about it, what I told you before, you would have came up with the same thing. So now I have terms, I have K in terms of L. Now I want to plug that in, and I can plug it into a bunch of different places. But what I did in the Lagrangian is I plugged it into our constraint, right? Which was essentially our production function. So I plug it into my production function, and I get Q is equal to W over V to the 0.5 times L. Am I going too fast? So now I have Q in terms of L, but I want to solve for L, right? So I do the algebra and I solve for L in terms of Q, W, and B. So I get L is equal to V over W to 0.5 times Q. This is exactly what we got when we did the cost minimizing function with the restriction in our Lagrangian. Okay. So now that I have L in terms of all fixed variables, non-random variables, I want to solve for K. Guess what? We had solved for K in terms of L before, in Lagrangian. Now I just plug that in, that L, into what we had for K before. Entonces yo quiero sustituir esto Aquí tengo pero aquí tengo acá en términos de él, yo quiero sustituir esto acá. Pero ya sigues el parcial. Tú tenías los dos parciales, la podías sustituir ahí, pero no puedes, no te va a funcionar sustituyéndolo en la ecuación de ganancia original. It has to be one of the partials.
Ok, aquí sin sustituir, porque era de aquí para la parcial. Ok, esto es. Entonces, ya una vez tengo esto, ¿verdad? Sustituyo por K.
Okay.
Por K,
Pues,
¿verdad? WL1. ¿Qué sucede? Aquí tengo G con este G a la negativo 0.5 me cancela. Entonces voy teniendo una función sin R.
sí, el problema es que la sustituiste aquí.
No puede sustituir. Porque esto es la derivada parcial de
Por dos razones. Primero, porque tienes P aquí, y vamos a get rid of it we can.
no pasa. ¿Qué fue lo que el paso anterior?
Ok, el paso anterior, ¿verdad? Aquí, primero yo quiero resolver por, entonces, yo tengo está bien, mi función de producción. I have my production function, right?
Okay.
So I substitute what I got, K,
¿Cuál es
in
la
terms of L
función?
into
¿Cuál es la función de producción? La de
Q,
igual, ok, ya.
punto 5.
Ok, sí. Entiendo.
Entonces, then I get L in terms of K, and then I can plug that L back into my function for K. Now, I could have done this inside the partials, but I can't do it inside the original property project.
Entonces tú lo escribes como una función de Q, de cantidad.
Sí.
Ah, ok. Y entonces ahí es que maximizas buscador. Ok.
En esta parte se puede despejar para cualquiera de las variables, ¿verdad?
Sí.
Ok, está. Y yo estaba haciendo por pi, después vi el punto 5 y lo
No, pero P es fijo.
Ok,
No es una variable. It's not a random variable.
ok. Entonces, ¿puede hacer por K o por E? ¿O por W?
Sí, no, por W y beta, esos también son fijos. Los variables aleatorios, los random variables aquí.
Aleatorio, sí.
Gracias. Okay, so now I had K in terms of L, so I put this into that function. Right, and I get K, W would be 0.5 times Q. Okay, have a safe trip. Okay, so there it is, K, the W would be 0.5 times Q. So now I have K and L, right, in terms of our fixed variables, W, V, and Q. Okay. And basically we got for L and K, what we got in Lagrangian, which means our profit maximizing levels of K and L are equal to our cost minimizing levels of K and L. And we noticed that right at the beginning, right, where our ratio of input prices is equal to our marginal products. Okay, the last exercise for tonight. Suppose I have a demand function, right? Q is equal to 200 minus 4P, and I have a total cost function, 0.75 times Q squared. The first thing I want to do is write out the inverse demand function. Now, we haven't talked a lot about the difference between a demand function and inverse demand function. It's very simple, right? We have our function of demand, right? It's a function of Q. I rewrite that as a function of P, right? That's basically the inverse of my demand function. That's my inverse demand function. So, I'll start you off. Our inverse demand function, I just solve for P, and I get P is equal to 50 minus 0.25 Q. Now, why do I want you guys to write the inverse demand function? Well, the reason I want you to write the inverse demand function is because I want to substitute that into our profit function. Right? So we know from the equation I have up there on the board that profit equals total revenue minus total cost. That's P times Q times minus total cost. So P times Q, now I have P as a function of Q. So I can get a function with only Q in it. Well, I won't have P anymore. So we'll only have one random variable. Okay. The next thing then, therefore, what I want you to do is write the profit function. Remember, our cost function is equal to 0.75. Is it Q squared or Q cubed? No, I can't remember. Pretty sure it's Q squared. So I want total revenue minus total cost when I give you the cost function. Okay. So total revenue is P times Q, and we know total cost. Right? So we'll start with total revenue, P times Q. But I have a function for P, so I have Q times 50 minus 0.25 Q. That's equal to 50Q minus 0.25 Q squared. That's my total revenue for the profit function. I simply have to subtract off our cost. Ahora en la ganancia solamente tienes el ingreso total, solamente restas costo total. Y el costo total está aquí. La puedes simplificar, es el punto 2. 5 menos 0.75. Okay, so now the profit function, I subtract off my total costs, and I get the following. 0.25 plus 50q minus 0.75. Q squared, I have q squared here. I have q squared here, negative and negative. That gives me just q squared, so I get 50q minus q squared. Questions? Costo total tal. .75. Ah, sí, estaba dado al principio. Ahí. Ahí. Okay. Okay. Ahora, now that we have a profit function, the next logical step is to maximize profit. How do we maximize profits? I take the derivative and I set it equal to. Okay. Actually, before I do that, the whole point of this exercise is to show something that we learned last week. So the first thing I want you to do is calculate the marginal revenue. You already calculated total revenue. Okay. So if I have total revenue, how do I get marginal revenue? It's the same answer as a while ago. Take the derivative. Ok, esa es ganancia. Yo al momento yo estoy pidiendo ingreso marginal. Aquí tienes ingreso total. Con esto vas a sacar el ingreso marginal. Eso es para ganancia, pero al momento, ¿no? Yo quiero tomar el ingreso total, ¿verdad? Y de esto sacar ingreso marginal. So to get marginal revenue, I take total revenue and I take the derivative. And I have partials here, but it's actually, it's not a partial, it's actually a derivative. But in either case, it's marginal revenue is equal to 50 minus 0.5Q. Is that what everybody got? So if we did marginal revenue, the next logical step is marginal cost. I gave you the total cost function, which was 0.75Q squared. Negative 0.75. Yeah, negative 75Q squared. How do I get marginal cost from that? Okay, MSA.
No sé para qué llega. Que sentirse bien con llegar a
Okay. Looks like everybody has it. So I take my total cost, I take the derivative, not the partial, the derivative. So I get 2 times 0.75Q or 1.5Q is marginal cost. So now, what I told you to do a while ago is you have the profit function, calculate the profit maximizing quantity of the firm, and the price of this firm once you do that quantity. I can do this in one of two ways. What we saw last week, I can set marginal revenue equal to marginal cost, Or I can simply take my profit function, take the derivative and set it equal to 0. Why don't you guys go ahead and take the profit function and take the derivative and set it equal to 0 and solve for Q. And you'll notice when you take the derivative, right, it's the same thing as taking marginal revenue, right, and making it equal to marginal cost. So you have marginal revenue minus marginal cost. Okay. So I have profits 50 of Q. I want to take the derivative, set that equal to Q. I get 50 minus 2Q is equal to 0, where Q equals 25. Okay. Once I have that, once I have Q is equal to 25, to solve for price, what I need to do is plug that 25 into my inverse demand function. Tienes 25 y vas al parte A. Sí, aquí con perdón, ese es exacto para precio. So the profit maximizing quantity is 25. And profit maximizing price is going to, therefore, I use my inverse demand function, which we saw in part A is 50 minus 0.25Q. I plug in 25 for Q, get P is equal to 50 minus 6.25, or P is equal to 43.75. And those are the examples for today. Are there any questions? Okay. Next week, I'm going to start covering aspects of perfect competition. And the week after that, we're going to have the first midterm. The stuff on perfect competition won't come on the first midterm. It's for the second midterm. Questions?
¿Va a ser más problemas así como lo que hicimos o va a ser como que de teoría hay que memorizarlo o va a ser aplicado como
los
problemas
que nos puso en la página?
Como los ejemplos, sí.
Okay.
Voy a tratar de hacerlos un chispito más. ¿Cuál es la diferencia? I was told that I have to lower the math a little bit.
Lo que pasa es que como que te tienes que entonces tratar de memorizar todo el material, a ver como que no olvidaste algo.
Y usted no sabe que
¿Por qué?
Sí.
Ah, sí, por eso.
Sí, era 9 capítulos. Yo prefiero así.
Pero es que ese nivel está muy bueno.
Sí, yo